This is problem number 26 from chapter 2. It reads, in coming to a stop, a car leaves skid marks 92 meters long on the highway. Assuming a deceleration of 7 meters per second, estimate the speed of the car just before braking. I'm going to make a little picture model here without making too detailed of a sketch. We've got the object. We'll say that it starts initially from this position, position 1, and it skids to a stop and ultimately ends up over here at position 2. The problem gives us some information. It talks to us about the displacement here, delta x being in this case 92 meters. And we also know that the velocity of the car, or when it reaches position 2 here, is going to be 0 meters per second because we're told that it comes to rest. And we can say that the initial velocity in this problem is given to us in the problem. Actually, it's not. It's what we're looking for. So we're looking for the initial velocity when we have skid marks of 92 meters and a final velocity of 0. We're given some additional information. We're given that the acceleration of the car is negative 7.00 meters per second. So we have the negative acceleration of the car. The book uses deceleration. Be careful with that word. And so, taking a look at these three things, V delta x, A, and V final, you should arrive at using the third equation. V final squared is equal to V initial squared plus 2A delta x, where everything is known except for V initial, which is what you're looking for. We're going to rearrange this equation for V naught. So that's going to become VF squared minus 2A delta x is equal to V initial squared. Now I'm going to take the square root of both sides, and that yields V final squared minus 2A delta x is equal to the initial velocity before the driver applied the brakes. Now we're ready to substitute. So in the next step, we'll just plug our numbers in. That becomes the square root of our final velocity, which is going to be 0 meters per second. Of course, squared is going to be 0 minus 2 times our acceleration, which is going to be negative 7.00 meters per second squared. And I need to multiply that by the horizontal displacement given to me in the problem as 92 meters. All of that is equal to my initial velocity. Once I throw that into my calculator, I get an initial velocity of 36 meters per second to 2 sig figs will be my initial velocity.